Right, this is Geometry and Construction, Semester 1 Review, Unit 2. So starting at number 13 here, it says a can of paint will tip over when the set, or a can of paint will tip over when set on a roof that has a pitch more than 3 to 5. Okay, so our pitch is our slope, which is rise over run. So slope is rise over run. Right, so a ratio of 3 to 5. So our rise is 3, our run is 5. Right, rise is 3, run is 5. That's going to be 0.6. Okay, so if we have a slope that's greater than 0.6, the paint can will tip over. If we have a slope less than 0.6, the paint can will not tip over. Okay, our slope here, right? We're not using the full 30, we're using 15 here, and then we're using the 10. So our slope is rise over run. The slope, the rise of our roof is 10, the run of our roof is 15, which is going to give us 0.67, 2/3, right? Rise over run. And so that is steeper. So will the paint can tip over? Yes. Okay, 0.67 is greater than 0.6. Okay, so yes, the paint can will tip over. All right, next question here. So we can look at these two triangles. Okay, so let's draw that one over here. All right, we have an X. All right, we have a 6 and we have a 9. All right, so we have two sides of a right triangle. We're looking for the third. That's going to be Pythagorean Theorem. So that's a squared plus b squared equals c squared. Right, c is your hypotenuse. It's across from the right angle. And then a and b are the two legs of your right triangle. So here we would have 6 squared plus 9 squared equals x squared. Okay, so that's 36 plus 81 equals x squared. Right, so that's going to be, may as well just put it in the calculator because we're going to have to take the square root anyways. So 81 plus 36 is going to be 117. To get rid of the square, you got to take the square root. So we're going to take the square root of 117, which gives me approximately 10.8. So x is going to equal 10.8, approximately. Okay. All right, and then we want to do the other one here as well. So if we do this one here, we have another right triangle. The base of that triangle is 12. The height is 5. We're looking for y. All right, so again, we have two sides of a right triangle, and we're looking for a third side, so we can use Pythagorean Theorem. So a squared plus b squared equals c squared. Okay, your two legs are 12 and 5, so that's 12 squared plus 5 squared equals y squared. Right, 144 plus 25. Right, 5 squared is 25 is y squared. Okay, that's 169 equals y squared. If you take the square root of both sides, you end up with 13 equals y. Really, it's plus or minus 13, but you can only have a positive length. So we're going to pick the positive 13. Okay, and then we want to know the combined length of all four boards. So we're going to take the two x values here, so 10.8, 13, 13, and then 10.8. Right, and add those all together. So 10.8 plus 10.8 plus 13 plus 13. Okay, and just to verify, I'll put it in the calculator as well. 47.6 feet. Okay, that's 14 there. 15, you and Bob go treasure hunting and lose each other, your GPS systems. Using your GPS system, you're able to get the basic coordinates of each other. What is the distance between you two? So for distance, we want to use the distance formula, right, which is the square root of the change in x squared, so x2 minus x1 squared, plus the change in y squared, so y2 minus y1 squared. Okay, the coordinates here for u, so this is going to be negative 3, 3. And then for Bob is going to be 4, 1. 4, 1. All right, so your two x values are negative 3 and 4, so we're going to do distance equals the square root. Your two x values are negative 3 and 4, so we're going to do negative 3 minus 4 squared plus, and then your two y values are 3 and 1, so we'll do 3 minus 1 squared. Okay, doesn't matter which order you put them in. If you would have done 4 minus negative 3, that would have been a positive 7 here. Right? But when you square it, it doesn't matter if it's negative 7 or positive 7. You're going to get 49 either way. And then same thing here. We did 3 minus 1, but we could have done 1 minus 3. That would have been negative 2. But negative 2 squared is going to be the same as 2 squared. All right? So it doesn't matter the order. Okay, but here we have negative 3 minus 4. That's negative 7 squared plus 3 minus 1 is 2 squared. So we get the square root of 49 plus 4, which is the square root of 53. Okay, which is going to be approximately, we can put that in our calculator, square root 53. 7.28, approximately 7.28. All right, so that's the distance between the two. All right, 16, 17, 18, and 19 are going to be volume problems. Okay, so the first one is the cylinder. Okay, so the volume of a cylinder, right, it's the area of the base times the height, so it's going to be pi r squared h for a cylinder. Volume of a cylinder. Okay. All right, plugging in the numbers. So we have volume equals, the radius of our circle here is 5. So pi times 5 squared, and then your height is 12. Okay, so volume is going to here equal, that's 25 times 12. So let me put that in again. Calculator went away. So 25 times 12 should be 300 or 400. 300, I'm sorry. So 300 pi. Okay, and if you want to multiply the pi in there, you can do that. We can do 300 times pi, and that's going to give you approximately 942.5. Okay, or 300 pi. Right, you could also do approximately, if you multiply that out, approximately 942.5. Okay, and we don't have units here, so we're just going to say units squared. All right, pyramid. So the volume formula for a pyramid, right, is 1/3 the volume of a rectangular prism. So the rectangular prism is length times width times height, and a pyramid is going to be 1/3 of that. So 1/3 length times width times height, right? Just like a cone is 1/3 of a cylinder. A pyramid is 1/3 of a rectangular prism. Okay, it's a square base. So if this piece is 200, this one over here is 200. Okay, and then the height is 90. So we're going to have 1/3 Length times width, 200 times 200. And then a height of 90. Okay, so that's going to give us, if we put that all in, 1/3 times 200 times 200 times 90. So 200 times 200 times 90 divided by 3. We're going to get 1,200,000 feet squared. It's quite a big pyramid, over 1 million square feet. Right, did we do that right? That seems a little excessive, doesn't it? 200 times 200 times 90 divided by 3. Nope, we're good. Okay, it's pretty tall. Pretty big space there. All right, 18 is the standard house. So we have a rectangular prism and a triangular prism. So let's start with a rectangular prism. So the volume there is going to be length times width times height. Okay, so our length and width is 28 and 40, and our height is 14. So the volume here is going to be 40 by 28 by 14. Okay, so we put that in our calculator, 28 by 40 times the height, which is 14. So the volume of that rectangular prism is 15,680 square feet. So 15,680 square feet. Okay, the volume for the triangular prism is going to be the area of the base, which is 1/2 base times height. Right, and then times the distance between the bases, which I'm going to call that capital H height. Okay, so this is 40. That's the distance between the bases. That's our capital H. This here is 28. Okay, that's your base. And then your height of your triangle here, right? This whole thing is 22, and this piece is 14. So 22, so this piece right here is 14. Right, so 22 minus 14 is going to be 8. So the height of that triangle, the height of that triangular prism is 8. So if we put that all in our equation here, we have 1/2. The base is 28 of the triangle. The height of the triangle is 8. And then the capital H, the distance between the bases, is going to be 40. Okay, so we can put that all into our calculator. 1/2 times 28 times 8 times 40 is 4,480. 4,480 feet squared. Right, and then so for the total, we're going to add these two together. So 4,480 plus 15,680. And that gives us total volume of 20,160 feet cubed. Okay. Volume is cubed. It's 3-dimensional. I don't know why I put squared. Okay. So research dome here, we got to find the volume of this research dome. Right, so we have a cylinder and then half of a sphere. So let's do the cylinder first. So the volume formula for a cylinder is pi r squared h. Okay. The radius of our cylinder is 14, right? Again, imagine this going all the way around. Okay, so the radius of our cylinder is 14, so that's pi times 14 squared. And then the height here is 8. Okay, so 14 times 14 times 8, 1,568 pi. So 1,568 times pi, feet squared, feet cubed. Okay, and then the area of a sphere, or I'm sorry, again, the volume of a sphere, keep saying area, that's going to be 4/3 pi r cubed. Okay, and again, we know the radius is 14, so that's going to be 4/3 pi, the radius is 14, so 14 cubed. Okay, so that's going to be 14 times 14 times 14. Okay, times 4 divided by 3. So that's not going to work out. It's going to give us a decimal. So I'm also going to multiply the pi in there as well. So times pi. And that gives us 11,494.0. So 11,494.0 feet squared. Okay, if we were to multiply this one out here, we'd have 1,568 times pi. So that's 4,926.0. 4,926.0 feet squared. Right, so I'm going to take those two numbers there and add them together. 11,494.0. And that gives us a grand total of 16,420.0 feet cubed. Okay. I don't know why I keep saying squared. It's feet cubed. It's volume, it's feet cubed. Okay. Find the volume of a baseball that measures 3.5 inches in diameter. So again, a baseball is a sphere. So the volume formula for a sphere is 4/3 pi r cubed. Okay, if the diameter is 3.5 inches, the radius is going to be half of that. So the radius is going to be 1.75. Okay, so we can simply plug that in then. 4/3 times pi times 1.75 to the third power. Okay, so my calculator here, I'm going to do 1.75 times 1.75 times 1.75 times pi times 4 divided by 3. And I got 22.4. So volume is approximately 22.4 inches cubed. Right, we got, looks like 2 more here on topic 2. So the I-70 grade west of Denver is 5%, right? So that's 0.05 as a decimal. The horizontal length of the highway is 5.5 miles. Okay. Right. We know the slope here, right? We want to find the rise, right? The elevation, right? And when we know our slope is 0.055%. Right, so slope equals rise over run. Okay, our slope is 0.05, so we can substitute that in here. Our rise is x, and our run is 5.5 miles. Right, and so we can multiply 5.5 on both sides. So 5.5, 5.5. Right, so 5.5 times 0.05 is 0.275. And that's miles. Okay, we want our answer in feet, so we got to convert miles to feet. So 0.275 miles. there are 5,280 feet in a mile. So 5,280 feet in 1 mile. Right, this way the miles cancel out. So 0.275 times 5,280, and that's 1,452 feet. 1,452 feet. Okay, that would be our elevation in feet. Our elevation in miles is 0.275. Our elevation in feet is 1,452. All right, we have a rectangular soccer field, 100 meters wide by 130 meters long. So 100 meters here, 130 meters here. The coach asks players to run from one corner to another diagonally across. Okay, what is the distance? Okay, well, we can use the Pythagorean theorem here. So we have two sides of a right triangle, and we're looking for the third side. So it's going to be a squared plus b squared equals c squared. So a and your b here would be your two legs. So 130 squared plus 100 squared equals c squared. So these are going to be some big numbers here. Okay, so 130 times 130 is 16,900. Okay, plus 10,000, right? Equals c squared. Okay, so 10,000 plus 16,900 is going to be 26,900. Right, and then to get rid of the square, you got to take the square root of both sides. So we want to take the square root of 26,900. And we get 164.0 feet. So 164.0. Okay, so x here is going to be 164.0 feet. Okay. And that's it for topic 2. We'll do a third video for the questions from unit 3.